Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 5A. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 8th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2024, Pune, India. The 8th edition of the conference is being organized in a hybrid mode. The physical event is organized today in Pune, India, and the virtual event was held through Zoom yesterday and is taking place today, that is 12th and 13th of January 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for the question and answers. On 7 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair for this session. We have with us Dr. Astha Parikh. She's a senior assistant professor in the Department of Computer Science at IIS, deemed to be University, Jaipur, since March 2010. Her research interests lie in the area of programming languages, data mining, cloud computing, sentimental analysis. We welcome you, ma'am. We'll be beginning with the papers. We have our first presenter for the session, Pavan H., with the paper titled A Comparative Study of Audio Source Separation Techniques on Indian Classical Music, Performance Evaluation and Analysis. You may please start with your presentation, sir.
Yeah, hi. Thank you, ma'am. I'll just share my screen.
Sure.
Also, please do let me know if my screen's move.
It is visible. Please go
Okay.
ahead.
Good afternoon to everyone present here. Our paper is based on music audio source separation techniques. Our team comprises of Abhishek Yagna, myself Pavan, and this project was done under the guidance of Dr. Ashwini ma'am, Department of Electronics, PS University. So the problem domain of music signal processing has gained a lot of traction in the recent few years due to the digital revolution of media storage, pre-processing, and its eventual distribution. Since music signals can be typically represented as a combination of percussive and harmonic components, an important pre-processing step in the of music signals has been to strip it into its sources. So we have based our work around this problem, separating the harmonic and the percussive, and thereby the instruments from a given music sample. Harmonic percussive music source separation can be implemented for a wide range of applications, such as automatic music transcription, drum beat detection, and remixing of songs, among other uses. So like a lot of research has been done with respect to this problem for Western music. But music being as vast and diverse as it is across different regions and cultures, the same said research may not hold good for other genres such as Indian classical music. Hence, our aim with this work is to explore and highlight the possibilities, nuances, and difficulties encountered while applying standard signal processing techniques to decompose an Indian music audio sample into its harmonic and its percussive counterparts. So this is the general workflow for all the methods that we have implemented in this paper. So we have implemented 4 methods, but all of them would initially involve converting the signal from the time domain to the frequency domain via the short time transform, Fourier transform. So yeah, I'll go over all of these 4 methods and we will evaluate them with respect to Indian classical music in consideration. So the first method is median filtering. Um, Median filtering is a signal processing tool which is used for a wide range of denoising applications due to its smoothing property, as it operates on a given sample by replacing the middle value with the median of the signals in the window around it. Um, So the application of this method in order to perform harmonic and percussive music source separation is sort of intuitively established on the assumption that harmonics can be regarded as outliers in a along the time axis, and percussive components can be regarded as outliers when it comes to the frequency axis. So median filtering is used on the spectrogram in both the horizontal and the vertical directions. Um, And so that gives us the enhanced spectrogram, the enhanced harmonic and the enhanced percussive spectrograms respectively. So after that, we use binary masking to generate masks, which are then applied on the original signal to get the actual components in the frequency domain. So that is followed by converting the frequency domain into the time domain signal by taking the inverse short time Fourier transform. So this is the block diagram for the method. So we apply median filters in both the horizontal and the vertical direction, which gives us the enhanced spectrograms respectively. We use these spectrograms to create a mask, which is then applied on the original signal, followed by the inverse Fourier transform. The next method would be non-negative matrix factorization. So unlike other decomposition methods like singular value decomposition and ICA, NMF constrains the products to be non-negative. As many real world scenarios, the quantities being modeled are inherently non-negative. So non-negative matrix factorization employs iterative decomposition to factorize the magnitude spectrogram into activations and template matrices using various cost functions for the harmonic and the percussive components. The objective is to minimize the cost function to achieve accurate separation. NMF also leads to parts-based representation of the data, which is what we want in this case, because here the music is essentially composed of harmonic and the percussive part. So here the data vectors are regarded to be columns of the matrix. The input vectors can be expressed as a weighted super, superposition of a number of template vectors according to some assumptions. The templates are represented by the columns of W, and the weights called activations appear in V. um, so, so we use this global objective function to carry out the decomposition into 4 non-negative matrices. This is done via um, multiplicative update rules, which essentially use the partial derivatives of the global objective function to convert the initially randomized values of the 4 required bases to their non-negative final forms. So what you see on the right is again the flowchart for this method as well. So next method would be the modified LPSS. Um, So pulsating change in pitch are called vibratos, and gliding tones of small frequency variations in the signal are called glissandos. So these vibratos and glissandos are represented diagonally, and it is these components that cannot be separated and and which cause unconditional distortion in the case of Indian music signals. So the aim with this method, with modifying this method, was to remove these diagonal components, thus aiding in better separation. The modified LPSS method is an extension to one of the papers that we referred by Ono, where the percussive and the harmonic streams are separated using a complementary diffusion method, which is also iterative. So on top of this, we apply another minimization function on the spectrographic results given by Ono's method by using one more function. The results produced by Ono's algorithm, when applied to Indian musical audio, will will contain percussion components in the harmonic stream, which we don't want. So with his method, one of the major drawbacks is that the diagonal component was not considered at all. Hence, we lose out on that information carried by the diagonal component. So here in our proposed or modified method, we consider the diagonal component, hence preserving the information and increasing the efficiency of the separation. So this is achieved by decomposing the diagonal components into its respective horizontal and vertical components, as you see in the graph on the right. Um, so yeah, and this is also iterative. So this is basically like a two-step refining process in a way. Again, the conversion to time domain at the end is all common for all of these methods because we initially convert it into the frequency domain. The last method is kernel additive modeling. So source separation using KM is a general method that can be used to separate multiple sources from a single source that can be expressed as the sum of many such multiple sources. And since the music signal in consideration can be also expressed as a sum of its harmonic and percussive sources, here it makes perfect sense to use KM as well. So the method of KM requires defining proximity kernels which have inherent properties of the sources that need to be separated from the original audio. The proximity kernels give the similarity between different locations present in the neighborhood of the kernel. So the similarity is based on the definition of the kernel itself. And here, since the defining properties of the harmonic and the percussive sources remain constant throughout the signal, we have chosen static kernels as opposed to dynamic ones. So the process for this would be that we take the input, which is clipped to 30 seconds of length, um, and then we express it in the frequency domain as usual, because in the time domain, you have no information only limited to the amplitude of the signal. Um, so you clip it to 30 seconds of length and you obtain the frequency spectrogram. The obtained spectrogram is then convoluted with its respective kernels to obtain the masks for the sources in the frequency domain. This is an iterative procedure. So unlike the other methods described previously, um, which depend on the update rules for the source separation, where the rules for the harmonic sources are dependent on the percussive and vice versa. Here in KM, they are independent from each other. Thus, if needed, one can only separate the harmonic source or the percussive source or both with different parameters and different kernels for each source. The spectrogram, that is, which are the masks from the previous step, are used to obtain the actual source, which is the input spectrogram for the next iteration. This iterative procedure helps in further refining the separation. Finally, the obtained spectrogram can be converted back into the time domain to obtain the separated sources. For the separation, through experimentation, we have found that we we sort of we use a horizontal Han window, and for the vertical window, we use a Kaiser window. So these are the kernels that you see. So this is a horizontal one, and this is a vertical kernel. Um, so so to evaluate our method, we have used harmonic ratio, which is also what most of the papers that we refer to also used, harmonic ratio or energy ratios. So harmonic ratio is essentially the ratio of the energy of the harmonic component to the total energy of the harmonic plus the percussive component. Percussive ratio is nothing but 1 minus the HR because both of them add to 1, sum up to 1. For our data set, we have used around 25 Indian music samples, each of 30-second duration from the Dunya data set. So these are some of the audio samples that we have taken into consideration. So this is how an input spectrum looks like. So here you can see that it's composed of both horizontal and vertical ridges. So this is the input, which is basically the mix of both harmonic and percussive components. So on performing the separation, on the left, you can see the harmonic audio, the separated harmonic audio. So here you can see distinct horizontal ridges. So these are basically localized in frequency, which would be the harmonics. And on the right side, you can see the separated percussive components, which are basically localized in the time domain as vertical ridges. So this would be the, for example, let's say Veena, and this would be percussive would be, let's say, like a tabla or the drums. So these are, so we have compared Ono's method with our modified method with respect
Excuse
to,
me, presenter. So I'm really sorry to disturb you, but this is a gentle reminder for the time limit.
yeah, I'm just almost done. Yeah.
Okay, okay.
Yeah, so these are our values which we have obtained for the HR for Ono's method and our method. So as you can see, we have obtained like a significant increase in the HR value, which is what we want. Um, so this is Ono's method and the modified LPSS method, which was again based on his method. We have also compared our modifications with KM as well. Again, as you can see here, the KM and the modified KM HRs, they have shown like considerable increase in their HR values, again, suggesting a better separation. So we've also taken processing time as one of the factors to evaluate the output, which is basically the entire time taken by the algorithm to separate the input into its components. So as we can see here, the fastest one was proved to be modified KM, with it processing around 9 seconds of input in 1 second. And the least would be modified LPSs. So in conclusion, this work explores and implements 4 separation techniques, the strengths and limitations of each method, which lead to further research for real-world applications. Median filtering emerged as an efficient, non-iterative method suitable for real-time separation, but with limited flexibility. Modified LPSs with its two-step refinement process and diagonal component projection excelled in producing high-quality harmonic components, but had high computational overhead. The modified KM approach offered great customizability, but with low computational requirements as well, which makes it a compelling option for musical contexts. NMF's performance was less optimal for Indian classical audio, warranting careful consideration for separation tasks. One of the main challenges we faced was determining the number of iterations required. So we have determined that for KM, we need around 10 iterations for the most optimal separation. Yeah. So these are our references that we have used in this research. Yeah, thank you.
Thank you, sir. Ma'am Astha, would you like to ask any question? It seems there might be a connectivity issue. Ma'am, we can't hear you. Ma'am, would you like for us to move on, or would you like to ask a question through the chat box? Sir Pavan, we have a question for you in the chat box.
Yeah, ma'am. So we have taken the data set from Dunya dataset. It's this open source Indian classical music dataset. And we have just taken instrumental music into consideration. We haven't yet explored vocal music as well, as in music that contains vocals. So we have mainly just considered instrumental Indian music. Yeah, ma'am. So like I explained, we have, so Indian music uh, doesn't really contain a lot of vibratos and glissandos, which we have observed to be mostly like a component of Western music for the most part, as a major part. So we had to deal with separating that out by taking the diagonal components and all of that. Plus, denoising is always a general um, challenge that we face in order to process the signal better initially. So in some cases, we had to denoise the signal as well using median filters or bandpass filters to, get the signal in the required frequency range. So, so the teacher we worked under, Dr. Ashwini ma'am, she herself is a classical artist, actually. So it was under her guidance that we had the separations done. I would show the demo, but I don't have it at the moment of the separated audio. But yeah, it's quite evident that that the separation has taken place pretty well. Yeah, thank you, ma'am.
Thank you, Ma'am Astha. Thank you, Sir Pavan. We'll be moving ahead with our next presenter. I'd like to
Thank you.
invite our next presenter, Neeta Yadav, with their paper titled A Comprehensive Analysis of Machine Learning Models for IDS. Ma'am, if you're ready, then you can go ahead. Ma'am Nita?
Hello, am I audible?
Yes, ma'am,
Hello.
you're audible.
Okay. So here I'm presenting my screen.
Sure, ma'am.
Okay. Is my screen visible?
Yes, ma'am, it is visible. Please go ahead.
Okay. Myself, Nita Jadhav. I'm here presenting my research paper on the comprehensive analysis of machine learning models for IDS system, which this paper is authored by Ms. Prathisha, Mr. Patsha, and myself. This is the outline of my presentation. First, introduction and related work, experimental setup, then ended with the conclusion and result discussion. So basically, what do we mean by IDS? IDS means intrusion detection system. It is a technique to protect the network against the attacks. And it is very necessary as a normal encryption method and access control cannot be able to detect several attacks. This is based. These kind of systems are based on the gathered data, and it will predict the intrusion depending on their particular characteristics or their patterns. Nowadays, there are lots of IDS research has been done, and based on the vast varieties of IDS system, it is crucial to assess and compare the effectiveness of different IDS models and techniques. So this paper aims to provide the comparative analysis and provide the research by aiding in the selection of appropriate data set, improving the reproducibility, productivity of the research outcome, and the effective machine learning model that can be applied for IDS system. This is the done to our experimental work, and we mainly focused on the research paper that are based on the comparative analysis, or they have worked in a similar domain. So the first paper, that is the comparative algorithm analysis for machine learning based intrusion detection system. This paper represents the comparison of competitive models like DNN, SVM, KNN, and K-means algorithm on the famous data set like UNSWNB and NSLKDD. The paper focuses on the parameters of machine learning models like precision, recall, and F1 score. The second paper referred as the comparative analysis on intrusion detection system through ML and DL techniques. This paper is mainly focusing on the DL and ML techniques which can be applied, and they haven't considered the computational complexity. And the performance is measured on the data set, that is NSL-KDD. Again, they have considered only one data set for the comparative analysis. The next is comparative evaluation of machine learning algorithms for network intrusion
Ma'am, can you hear me?
detection. Yes, yes. Hello, hello, hello,
Yes, ma'am.
hello.
Ma'am Nita, please continue.
Yes, yes, okay. So the next paper is based on the intrusion detection and attack classification. This paper also aims the machine learning model that aids the attack classification as well as detection. So they focused on the machine learning models like SVM, KNN, RF, K-means, DBScan, and ANN. The data set they have considered in wide varieties like KDD 99, NSL KDD, UNSW NV15, and CICIDS 2017. They discovered that the random forest is the most suitable for IDS system. Again, the survey continues to the next paper. that the comparison performance for machine learning techniques for intrusion detection. That is a paper under the Manager's Journal on Computer Science. Again, this paper is mainly focused on the NSL KDD data set, and the analysis of ML model like NeoBias, Random Forest, SVM, XGBoost are considered. They mainly focus on the accuracy parameter for identification of better ML model. Next paper is under the computer security, that is the review of intrusion detection system, that is comparative analysis, and also focuses on the research challenges faced by this paper. Again, this paper focuses only one data set, that is CICADS 2017, and they consider wide range of features from this data set to evaluate the supervised learning model only. Next paper is the generating a new intrusion detection data set, that is focusing on the uh, competitive data identification data set that helps the ML model to gain better accuracy, and they identify the best features to detect the certain attacks category. According to this survey, there is a need of identification of better model that provides the computational complexity, as all these surveys have not identified the computational complexity as a parameter for evaluating the ML model. So for that, we considered this work, and for this work, we have considered these three main data sets: CICADS 2017, IoT dataset, and UNRIDD. The reason behind choosing these data sets is the only that they are providing the recent network configurations also. Uh, while choosing this data set, we faced several challenges because to gain the accuracy on the ML model, it is required that we have sufficient amount of data set. Any missing data or lack of information in the data set may occur the less efficient model, or may contribute to the or may deteriorate the accuracy of even higher accurate model. So the main challenge is to find out the data set that has the detailed network characteristics. Also, the main challenge is to identify the characteristics on the recent networks. There should be a more general data set that evaluates the performance of machine learning model, because our aim is to identify the best suitable machine learning model in all aspects. There are also many unrecognized patterns of attacks. As till now, we have identified attacks that are very common in behavior, and we can easily able to identify them. But as our network evolves and new technologies has been evolved, so there can be different types of attacks which have unrecognized pattern. So we need to also consider them for our work. This is the description of the data set that we have chosen. Here we list out the several attack category that our data set covers. The first data set, CICADS 2017, which is the intrusion detection data set in the network traffic. It based on the general virtual traffic data set, and it has the major attack categories that is listed out here. Again, this data set has the 5 different attack category. So we can use this data set for multi-class classification also, as well as binary classification also. And it is based on the virtual simulated environment. So again, there is no real time and characteristics provided by the CADS 2017. So to complement this data set, we also have taken another data sets, that is UNR IDD data set. This IDD data set is based on the dynamic topology, which provides the feature with lots of diversity, and also identify attacks which have unrecognized patterns. The major attack categories identified over here, that is listed out here, like Modbus protocol attack, unauthorized access attempts, protocol anomalies, command injection attacks, malware activity, system tampering. All these attack categories are listed out under this data set. And to cater the need of analyzing the recent network identification, we have taken another recent network-based data set, that is IoT data set, which targets the Internet of Things network. And the major attack categories are defined under this data set is a denial of service attack, that is particularly for IoT devices, and command injection attacks, code execution attacks, authentication bypass, network scanning, malware infection, and malicious firmware update. All these data sets have covered most of the network characteristics. So we have taken this for our comparison. And if model is working fine with these three data set, then the model has the efficiency to work with all kinds of network related data set. Then the machine learning model. For choosing machine learning model, we have considered several parameters, and our main focus is on the lower computational complexity. Because of the need of the IDS system, they don't require much computational complexity. Chosen models are decision tree, linear discriminant analysis, random forest, multi-layer perceptron, and Gaussian naive Bayes. Again, this model is aimed to discriminate between the two categories, that is regular traffic and abnormal traffic. So we haven't done the classification on the based on the particular tech category, but we just identify the binary classification as a regular or abnormal. Again, the main important parameter that we have considered is the effective handling of massive amount of data. As we are aware that even in IoT network also, the data is generated in a huge amount, and to handle this huge amount of data, model should be a robust. So that is also considered for choosing the models. And The main parameters we have considered is the model complexity, learning rate of model, data pre-processing, model accuracy on test data set, and requirement of trained data set. As Considering the criteria that detailed data set may not be available every time, so ML model should be robust for the less amount of training data set. So we also considered that criteria for considering the analysis. So these are the result and discussion. Results that we identified after comparing all the ML models. We implement all these models using Python technology, and on the data set is achieved from the Kaggle data set. Also, we contacted the author to get the data set, and we also consider the different parameters that model is trained with the less amount of data set, then it is trained with equal amount of data set, and see the accuracy that is achieved on a particular ML model. So we can see over here that the decision tree is providing the economical solution for all the data set for detecting the intrusion, even with the smaller size of training data. So the performance of model varies across data set and test sizes. We can conclude that. And decision tree and random forest model generally performed well across the different data set according to our result. The MLP and GNB models had the lower accuracy. So they They are not more robust for the IDS system. Even train size affects the model performance. Inappropriate train size may result in inefficiency, and it is important to consider the characteristics of data set and the specific requirement of the application whenever we are selecting the appropriate models. To conclude, we have given the comparative analysis of data set for the IDS research that provides the valuable insights, and main focus is on the factors such as size and computational complexity of the model that we require for our IDS system. So it provides the economical solution for our IDS system, and we also use the benchmark data sets that highlight the fair comparisons, and we can employ the fairness among the comparison. The analysis emphasizes the importance of real world data and also comprehensive analysis for robust evaluation. The standardization of data set characteristics and evaluation metrics are crucial. So, according to that, we provide this analysis. Overall, this research contributes to the advancement of IDS research by aiding researchers in making informed decision and promoting transparency and reproducibility in the field. So this will be useful for the researchers who are doing their IDS system, and they want to choose a better model or economical model for their IDS systems. These are the references that we have considered for our work. Thank you. So this is it from my side.
Thank you, ma'am. We'll be proceeding with the questions. Ma'am Astha, would you like to ask any question? Ma'am Neeta, we have a question for you in the chat box.
Yes, ma'am. We consider the mainly computational complexity and size parameters, and the text categories are already given by the data set. So the feature sets are not that much considered, but mainly focuses on the model parameters like train size and their uh, test accuracy. Yes, for the IoT data set, the data was not up to the mark or not in a detailed manner. So for that, we have the lower accuracy for all the kinds of models. So in that particular scenario, we face the challenges like the models is not working same as the other data set that has the traditional instances of intrusions.
Thank you, ma'am.
Okay.
We'll be proceeding with the next presenter. I'd like to invite paper presenter Anat Kumar Singh to present the paper titled Anxiety, Depression, Red Flag Marker in Social Media. So you may start your presentation.
Sure. Let me know once the screen is visible.
It is visible now.
Okay. So, hey everyone. So today our topic is anxiety and depression red flag marker in social media, a tool that can help determine the mental health issue. And the members we have in this group for this project is Siddhant Srivastav, Dipaman Das, Kabrul Hashem, Ronak Mandal, and Anand Kumar Singh. And we have done this project under the mentorship of Dr. Shantafani ma'am, the HOD of Bengal Institute of Technology, Kolkata. Proceeding forward, we have a table of content that contains that we are going to talk about the abstract, introduction, proposed method, application development, future enhancement, and conclusion. So, for the abstract, so in this project, we have tried to tackle the ever rising issue in the mental health that is being neglected by common mass even today. We have used the dataset that was available on Kaggle, which was labeled. Thus, we decide to use some supervised machine learning methods to get a model that would help us predict the nature of an online post or comments and help us achieve our goal. We also tried out the convolutional neural network, the CNN, and we got the best results from it. And thus, it is the model working in the application in the backend of our extension we have built on this project. Moving forward for the introduction of this project, as I have earlier mentioned, our main objective for the project was to tackle the need for solution of mental health related issues faced by an individual. Our project act as a medium to detect such issues in an earlier stage and provide appropriate solutions as soon as possible, so that it doesn't unfold only something disastrous later on. So what exactly it is doing that we have created a solution that is going to detect whether a mental health of a user uh, is good or not based on the blog post or the articles that he's posting on the social media platform. So the proposed methods that we are doing, we have four proposed methods: the data gathering, data pre-processing, creating TF-IDF metrics for our model, and choosing the optimal model based on the results. For the data gathering, the objective of this paper is to develop a sentiment classification system using the standard data set, which we got from the Kaggle, that contains 1.6 million of tweets that were extracted from the Twitter API, and it contains certain polarity related to each and every blog post. The polarity that we are using over here are negative and positive, which represent the sentiment of a particular test. It's a labeled data since we are working on a supervised learning. And the columns that we have in this data set are the target, which also corresponds to the polarity of a tweet, the ID, the unique ID each and every blog post have, the date when it was written, the username, and the content, the blog post. Proceeding forward, after getting this data, we are pre-processing the data. So we are following certain steps to pre-process the data to remove all the punctuation, the stop words. What we are doing, we are extracting the data from the data set, and we are using the user ID, text, and target columns for our purpose, for our model. And then we are tokenizing the data. All the blog posts we are splitting into words, different words. And then we are removing the stop words, we are removing the punctuations, and we are lemmatizing the data into the base root form. Post the data gathering and data pre-processing, we are trying to create a TF-IDF metrics of it, so that we could determine the frequency of each and every words present in the entire data set, and it would help our model to get trained pretty well based on the frequency of words. Alongside, since we are also using the CNN model, we are also using the bag of words and word to vec. The bag of words, we are splitting the words into two lists, the positive list and the negative list, based on the polarity we are getting from the words. And the word to vec we are using to convert each and every words into a certain number, a meaningful number that will be used uh, within our model. And we ran our processed data into several models like logistic regressions, naive bayes, decision tree, random forest, and CNN. And these are the accuracies that we get. From the logistic regression, we get 72.84 percentage, and from naive base 71.56, decision tree returned a 68.48 percentage, random forest with 72.80, and the CNN that returned the best accuracy among all them was 75.56. Hence, based on the proposed method and our results, we choose the CNN for our application development. Our application, for the application of this project, we have created a extension, a Google Chrome extension, considering the policies of the platforms, we have created an extension since we are limited to extracting the data from any private accounts. So the main goal of this extension is to just demonstrate for the initial stage of our project. Basically, we can open a blog post. Let's say we have opened a Twitter. Over there we can just select any of the blogs, and the selected text will be sent back to the backend via our extension. Then our backend will process the received data, and it will remove all the punctuation stop words. It will just pre-process the data, and it will return the result from our model that our model is going to return to the front end. Then response we get from the backend, we will be showing the data on the front end whether the blog post selected is related to anxiety or depression, or is it a positive blog post. You can see in the image as well. Moving forward, and we can based on the percentage that we are going to get from the backend, we can show various result, and we are showing actually three results from the percentage of polarity we are getting from the backend, which is the negative, positive, and neutral. That means whether a post is related to anxiety or depression detection, the extension is going to show the negative result. And if it is positive, whether if the post related to the happy output, then we will be showing just the positive, and neutral is for the neutral blog post. Proceeding forward, we are in this image we are showing the neutral output as well. And the future enhancement that we have thought of for this project is we can proceeding forward, we can, instead of doing a manual task of selecting any particular blog post, we will be extracting the data we are present currently at. We will be extracting each and every data, each and every blog post related to a user, and we will send the data back to the backend. The backend will pre-process it and get the result from the model, and the result we will be getting from the model will be sent back to the front end, and the front end then, based on the results that we have got, we can process further to provide any help, or to provide any help to the user if the data found related to the anxiety or depression. We can proceed forward with helping the user, since some of the user might not be aware that they are suffering from the depression and they need an assistance. So we can proceed forward with it. So these are the future enhancements we are thinking of. Concluding our project. So, to conclude, this was our attempt to solve the growing issue of the mental health. Although it might not have significant impact now, but we sincerely believe the problem, which is lingering and growing in our society, needs to be addressed with high significant and through even more development in technology. And by introducing the methods that we discussed under future possible advancement, we believe humanity will eventually and definitely is not going to suffer much from the depression and anxiety. Then, minimizing the issue to the lowest possible phase. We thank our mentor to helping us through this journey, and these are the references that we took help from. So, yeah, that's all about our presentation. Thank you. Let me know if you have any questions.
Thank you, sir. Ma'am doesn't have any questions for you, so we'll be moving on with our next presenter.
Thank you.
I'd like to invite our next paper presenter, Arya Mujamdar, to present the paper titled Cancer Classification Using Gene Expression Data. Ma'am, you can start your presentation.
Yes, thank you.
It is visible, right?
Yeah, it is visible. Please go ahead.
Good afternoon, everyone. So we are here to present our research paper. The ID is 48, and the paper title is Cancer Classification Using Gene Expression Data. The name of presenter are Arya Muzumdar, Pranjali Joshi, Sachal Hablani, Vedant Khirgade.
Next slide.
So this is the roadmap for our presentation. So let's move ahead. So the field of genomics has been transforming the way cancer is diagnosed, treated, and managed. One of the promising approaches in this field is the use of machine learning models to predict cancer risk and develop personalized treatment plans. Our presentation will delve into the concept of genomic prediction on cancer using machine learning models, the research advancements in this area, and the potential impact of this technology on cancer care. So what is cancer? Cancer is a term used for a group of illness caused by uncontrolled growth of abnormal cells that can spread to different parts of the body. According to World Health Organization, cancer is the second leading cause of death after cardiovascular diseases. What is a genome? A genome is a complete set of genetic material, including genes and non-coding sequences, contained within the DNA of an organism. So a genome is basically like an instruction manual for an organism. It contains all the information that tells the cells how to work and what to do. It is basically made up of DNA, which is like a long code with different letters that spell out specific instructions.
Excuse me, ma'am. Really
Yes.
sorry to disturb you, but our chair wishes to see the objectives and experiment. They have written in the chat box. You can check it there. Please proceed with the objectives and experiment.
Okay, sure.
Thank you.
Sachal, you can continue.
Now, our problem definition. Our objective is to develop a machine learning model for classification of various cancer types using the UCI cancer dataset. The study will use a machine learning approach to train and test the model and will evaluate its performance using a range of metrics such as accuracy, precision, and recall. The findings of this research could have important implications for cancer diagnosis, prognosis, and treatment, and could help inform the development of personalized medicine approaches for cancer patients. Next. Next slide.
Literature review. The several methods have been proposed on prediction of genome at cancer in cancer disease. The several techniques have used different algorithms and achieved different accuracies. We have observed that the research paper which used certain ML approaches with effective feature learning and transfer learning, feature engineering and transfer learning have achieved great results. The table shows the research paper that we have studied for our project and their respective accuracies. Next slide. We conclude that the several
Skip this
approaches.
literature review part. Skip this literature review part and come to experiment.
Okay.
Okay, ma'am. So the methodology that we used is first we collected the gene expression data. We used the UCI machine learning repositories gene expression data. It is also known as the PanCan dataset. The variables of each samples are the RNA sequence gene expression levels measured by Illumina high sequence platform. The gene expression levels in this dataset refer to the amount of RNA produced by a particular gene in a sample. So this dataset contains gene expressions of patients having different types of tumors: breast cancer, kidney renal cancer, colon cancer, lung adenocarcinoma, and prostate adenocarcinoma. Next step was to pre-process this data. So data pre-processing in machine learning is a pivotal stage, and this helps to elevate our data's quality and enables the extraction of valuable insights. Real-world data is often incomplete, inconsistent, inaccurate, and has missing attribute values. So here we used mean imputation to fill in missing values in the gene expression data. Further, we had to convert some categorical variables to the numerical ones, and we performed normalization of all the values before starting to train the ML models. Every machine learning dataset must be split into a training set and a test set. The model is trained with the help of a training set, and then the test set was utilized for outcome prediction. So the first machine learning algorithm that we used was K-nearest neighbor. Next slide. So KNN is a supervised learning algorithm, and it does not make any underlying assumptions about distribution of data. It takes minimum time for training time for classification and can come up with a highly flexible decision boundary by just adjusting the value of K. It can be used to classify these cancer subtypes, and further, it can also be used to predict the response to different cancer treatments. Next slide. Next, we also implemented support vector machine. The objective was to find a hyperplane in an n-dimensional space. The dimension of the hyperplane would depend upon the number of features. SVM is highly effective in high-dimensional cases such as ours. It is memory efficient because it uses a subset of the training points, which are known as the support vectors. Then different kernel functions could also be used, and it is possible to specify custom kernels. Next. Next, we implemented random forest. A random forest is an ensemble learning algorithm where we combine multiple trees to predict the class of the dataset. It enhances the accuracy by preventing overfitting and is also capable of handling large datasets with high dimensionality. It takes less training time, and it is good for dealing with high dimensional data such as gene expression. Next. Logistic regression employs functions known as logit functions, and this helps to establish a connection between the dependent variable and the independent variables by forecasting the likelihood of event occurring. These logistic functions transform these probabilities into binary values, facilitating the use for prediction purposes. Next. So let us look at the results now. So for k nearest neighbors, we obtain an accuracy of 94.9%. For a support vector machine, 95.6%. For random forest, 95.2%. And for logistic regression, 95.8%. Next. Further, we also calculated the precision and recall for all of these algorithms, and you can see them in the table. We chose a model based on the computational complexity of the algorithm. K-nearest neighbor can be computationally expensive when dealing with large data sets. Models like logistic regression or random forest are more suitable when computational efficiency is a concern. So as logistic regression, as we've seen, has more accuracy than random forest, it was more suitable for this study. In conclusion, this study successfully classified between the various types of cancer with 95.8% accuracy, and the model used was logistic regression. This study can be further extended to use some other model and diverse datasets if needed in the future to train on models and also predict whether a person would develop cancer or not. Next. These are the references that we've used. And thank you.
Thank you, ma'am. We'll be taking questions now. Ma'am Asta, would you like to ask any question?
Yeah. Are there any challenges or considerations in integrating your model into current clinical practices?
Yes, ma'am. So the most major challenge would be the availability of those gene expression data. So right now, we only obtained data that was cancerous. We didn't get data from healthy individuals, those who didn't have cancer. So like the model would not be able to, like, given a person's gene expression data, the model would not be able to predict if the person doesn't have cancer. It would only be able to predict if the person has a certain type of cancer.
Okay.
So for that, we would require a healthy person's gene expression data also, and that is not available.
Okay. And what are the potential areas, for further research or improvement in cancer classification using gene expression data?
Ma'am, this further
Based on
one
findings.
important one future scope is personalized medication development for that. So we can use the gene expression data and the findings of it to see whether what type of like building a chemotherapy or some sort of medical plan for that patient.
Were there any unexpected findings or insight gained from the analysis of your model predictions? Were there any unexpected findings over there?
Not really.
Okay.
No unexpected findings.
Okay. Okay. Thank you.
Thank you, ma'am.
Thank you, ma'am. We'll be proceeding with our next participant. I'd like to invite paper presenter Ruchi Rathi to present the paper titled Design and Implementation of First in First Out Buffer for Distributed Load Balancing Systems. You may start your presentation.
Yes, ma'am. So my name is Ruchi Rathi and I am going to present on the topic Design and Implementation of First in First Out Buffer for Distributed Load Balancing System. So these are the outlines for the today's presentation: introduction, literature survey, FIFO working followed by FIFO architecture, testing and validation, testing on FPGA platform, conclusions, future prospects and references. So load balancing in distributed system.
Come to the objectives and experiment part.
Okay, ma'am.
Thanks.
So we have focused just on the design and implementation of FIFO buffer, design and implementation of FIFO buffer. So its working is as follows. So basically the FIFO buffer can effectively control two systems which can operate at a different speed, which is writing into FIFO and reading from the FIFO buffer. With this diagram, we can see that read and write pointers are being used, which are used to maintain the read and write address values linked to the memory array. So for first case, since there is no data, the read and write pointers are pointing to the same memory location. When data is written into the FIFO buffer, the write pointer is incremented, but read pointer stays at the 0th location. If we read the data 0 as shown in the C part, the read pointer is incremented by 1 and pointing to the next memory location. And likewise, this happens and the read pointer is implemented when data 1 is also read out of the FIFO buffer. So there are two conditions, empty FIFO and full FIFO. Empty FIFO is the condition where pointers are pointing at the same address and no data is being left to be read. For full FIFOs, the pointers are again pointing to the same, both the pointers are pointing at the same address, but the FIFO buffer cannot accept any more data. The FIFO architecture that has been implemented has following blocks: the dual port SRAM, which allows simultaneous read and write operation from two different ports. Its name is dual port. So it has an independent access for reading and writing part. Read and write pointers, which indicates the current position for reading and writing the data into buffer. So read logic, write logic, which has an input of read address, write address, read pointer, and write pointer. Enqueuing is when the data is written into buffer at a designated location indicated by the write pointer. The write pointer is performed on one port of the dual RAM. After writing, the write pointers are incremented to the subsequent position in the buffer. For dequeuing, to retrieve the data from the buffer, that is returned, the data is being removed from the buffer after reading the data. The control logic or the state signal block is used to manage the read and write operation and also to handle the empty and the full status signals. After this, the testing and validation has been done for the synchronous FIFO buffer using Verilog HDL coding on the Vivado software tool version 2016.2. RTL and timing assessments are accomplished using the Verilog test bench code. And after the software testing part, we have dumped the code to the diligent FPGA Nexus 4 board to verify the designed RTL code. For just testing purpose, we have chosen the data width and the depth to be respectively set as 8-bit and 16 cells respectively. So in this, we can see that clock has been given which manages the read as well as the writing part. Reset condition has been given. Read enable signal, write enable signal, data in of 8 bits, data out of 8 bits, FIFO empty, FIFO full condition. So when read enable, write enable is given, data is written into the buffer, and before that empty signal was on, and after the write enable signal and data has been written, the empty signal is turned off. As soon as we give a read signal, data has been read out and the empty signal again becomes on. This is the one test case where we are writing and reading and displaying the empty signal. Other case is when we are continuously writing the data into the buffer until the FIFO full signal is on, indicated by the FIFO full signal. So when it won't accept any further data if we are adding to the FIFO buffer. The next condition is we are reading the data continuously until the empty signal becomes on. Even after giving again a read enable signal, since the data has all the data has been read off, nothing that read enable signal part is being ignored. So after testing on the software part by conforming it to the waveform, we tested on the Xilinx FPGA platform. So by giving various input and output constraints in the constraint file present in the Vivado software, like for input we have given switches, means for writing into the buffer, we are using the switches. These are the switches which is present on the FPGA board. Control signals like read enable, write enable, resets are present, are given by the push button. Output data and the flag signal responses like reading the data and the flag signals like empty and full signals are displayed by the LEDs as shown here. So firstly, the FIFO empty signal is shown by the 8 LED. Then after that, right enable button, using the right enable, pressing the right enable button, we are writing into the FIFO using the switches. After that, we are reading the data from the FIFO by shown by the LED. And after reading, after writing continuously to the FIFO buffer, if the FIFO buffer is full, then it is indicated by the 10 LED present on the FPGA board. So the results are as follows. So the data width of 8 bits and FIFO depth of 16 cells, area utilization is of 0.03%. Therefore, a low area design has been proposed. Power consumption of 112 milliwatts with a maximum delay of 9.554 nanoseconds has been verified. Since these all data all these are being calculated for 8 bits and 16 cells, which is of just testing purpose. So for practical purposes, we have used a parameterized Verilog coding style so that it can be extended to more data with and accommodate more data into the FIFO. So for future projects and innovations, and integrate this FIFO buffer with system on chip design in today's world, SOC has become a very important part in which various FIFO buffers can be integrated. Similarly, we can use it for emerging technologies like in AI, IoT, for storing purposes. We can enhance reliability and security by integrating it for fault tolerance, security against potential attacks, breaches, etc. We can also make a FIFO buffer for specific applications by optimizing their timing characteristics, powers, or any other specific application. These are the references that we have used for our paper. Thank you.
Thank you, ma'am. Ma'am Asta, would you like to ask any question?
Yes. So what advantages, or you can say disadvantages, does the FIFO buffer offer in comparison to, alternate approaches?
Ma'am, it's basically used for storage purpose. So advantages are like if we don't want the space of the our memory to be wasted, like if there is a normal memory, so that random data could be stored in the memory. But in FIFO, it's like the data that enters first leaves out all. We have written into the buffer, and after we are reading it, the data is not being stored into the buffer, data is being removed. So this is the advantage, that means it consumes less area, and data is not being consuming more specific storage
Thank
area.
you. Thank you so much.
Okay.
Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Apoorv Parsodia to present their paper titled Design of Low Power Booth Multiplier with an Enhanced Pre-Logic Mechanism using Verilog. So you may start your presentation.
Sure. Thank you, Shita. I hope my screen is visible.
Yes, sir, it is visible.
Good afternoon, everyone. My name is Apoorv Parsodia. I'm from NIT Kurukshetra, and my co-author is Dr. Poonam Jindal. And today we are going to propose one low-power booth multiplier with enhanced pre-logic mechanism using Verilog. So Verilog is a hardware descriptive language, and this project we are designing on Xilinx software, which is open source software using the version of 2020.2. So the main content of this presentation will be the motivation behind designing of this algorithm and multiplier. We will be seeing the boot multiplier algorithm, traditional multiplier which has been currently using, and proposed design of multiplier, the proposed multiplier architecture, and RTL design of proposed multiplier which we are getting after hardware distributed language Verilog. Results of this design and conclusion and future scopes. So the main motivation for designing this booth multiplier is this multiplication is commonly used digital circuits. Whereas in like ML algorithm, we can see the vast usage of multiplier, DSP also, signal filter, like various artificial neural network are there where multiplication is extensively used. So performing high speed and low power consumption is the critical requirement of modern electronic circuits. So this new approach proposed is to reduce the power consumption by minimizing the switching activity in the circuits. Like later on slides, we are looking into like how this power is reduced by reducing this switching activity by designing this pre-logic design to generate enable signal that prevent from reductant working of multiplier. So what does Booth algorithm suggest? So here there is a two multiplicand and multiplier. We are multiplying this 2 digits. So this multiplier is passed on to encoder logics, which collects this three consecutive bits of a multiplier and encoded in such a way that multiplication task is reduced. So based on 3 consecutive digits, like if we get 000, so it generate the enable signal. It generate the signal which is multiplied with multiplicand A. So if we get like 00 here and A is passed and it get multiplied with 0 and partial product is generated. And similarly in this fashion, if 001 condition is triggered, so 1 is multiplied, which is generated by this encoder logics. Similar in this fashion, this encoder logic is generating a signal which is copy, shift, and 2's complement. So based on this signal, it is multiplying with multiplicand and generating this partial product. So our main motivation of this proposed multiplier is to reduce this switching activity by reducing this algorithm. So if you can see, like if we get triggered, if we get this 001 condition and 11 condition, the zero result is generating is a 0. So there is a no unnecessary switching of multiplier, which we are going to see like why, how can we reduce this unnecessary switching in the further slide. So this is the traditional multiplier which is operating. So this is the encoder logic and this is the decoder logic, which we are simultaneously applying to this logic, and it is generating the partial product. So when 000 and 11 condition also triggered, it is still working. So our main task is to predetermine those conditions and generate those enable signals such that this encoder and decoder won't work. So here we are proposing a pre-encoder which generate this enable signal such that this traditional multiplier won't work. So it directly sets this partial product to 0. As you can see here, we are simultaneously applying this multiplier bit to both traditional encoder and to pre-encoder. If 000 condition occurred, so it generates the enable signal, which is a negative of this. If it is triggered, so this both multiplier and this mux decoder will won't work. Rest of the condition, it is performing similar as well. So here is the main agenda of this pre-encoder design is to generate those enable signals such that traditional multiplier won't work. As you can see, if enable signal is low, partial product is directly set to 0 without performing any any multiplication. So this is the RTL design which we are getting after writing those Verilog codes. So here is the main pre-logic path, which is going to encoder and decoder. If this pre-logic part is generating enable signal, which is passing to encoder, that it won't work, it directly setting to partial product to 0. So this is the schematic of encoder after writing this Verilog code. And in pre-logic code, we have ensured that there won't be any glitch phenomena such that there is an unnecessary power consumption is there. So in glitch phenomenon, like if signals are like design is not very accurate, there is a consumption of power. So we ensure that there is a won't any glitch and return such a code that won't consume much power. So these are the results we are getting after all the analysis and all the factors after taken care. So in these results, there are two power two static power and dynamic power. So this dynamic power is mainly because of the switching activity. So we have taken care that switching activity of overall design is low. So thus we can see the significant reduction in the dynamic power. In traditional amplifier, traditional multiplier, it is 14.021 watt. In dynamic, it is 13.6. In static also, we can see the reduction. Total power is reduced by 5.082%, and dynamic power is reduced by 3%, and static power consumption is reduced by 71%. So in the design, we are adding the pre-logic. The main task is to it should be speed should be the also increase. So we ensure that the timing of pre-logic should be a very less, such that it is directly while generating enable signal, it should reach to decoder and encoder such a fast that it can directly set to 0, so that we can see the significant amount of reduction in the delay as well. LUT utilization is also less compared to the proposed compared to traditional multiplier. Sorry?
Come to the conclusion part.
Okay, sure. This is the simulation results we are getting. Conclusion part is the number of LUT utilized, critical path delay, and power consumption for proposed 8-bit booth radix 4 multiplier with improved design are reduced as compared to traditional design. So as we can see, the total power is reduced by 5%. Dynamic power consumption is also reduced by 3%. Static power is significantly reduced by 71%, and reduction of 1.26 nanosecond delay. Reduction of LUT is also 17.8%. And future scope, here we are implementing this adder with ripple adder. So for other adder also can be implemented, like carry look header and other adder. So this such that the addition part of partial product also can get reduced. So yeah, these are the future scopes. This was the presentation. Any question? These are
Nice
the
presentation. No, I don't have no questions.
Thank you, sir. We'll be proceeding with our next presenter. I'd like to invite paper presenter Pradyuma to present the paper titled From Open Defecation to Digital Empowerment, a Participatory IoT Solution for a Rural South Indian Village.
Good afternoon. Please let me know when my screen is visible.
Sure, sir.
Is it visible?
Yes, sir, it is visible. Please go ahead.
Thank you. Good afternoon. I would first of all, I would like to thank all the co-authors, Atira Santosh, Ekta Girish Kamath, Edmund, and myself, under the guidance of Mr. Narendra SM. So our topic is water.
Just wait a second. Ma'am, you shared the paper title From Open Defection to Digital Empowerment.
Sorry?
What is your presentation title?
Water and Sanitation Management for Kurukurda Village, Semi-Sustainable Model for Rural Development Living Lab.
Ma'am, you shared the another slide?
Sorry?
Actually, let me just share the flyer again. The topic in the flyer is different.
Yeah, that's what. Yeah.
So basically, this was we had done all the gathering, we have observing and all the collection of
Hey,
data.
what is your paper title? Paper title.
This what is there in the PPT, ma'am? That is the paper title.
But ma'am is showing from open defecation to digital empowerment.
Yeah, that open defecation, that is the major problem to digital empowerment. It is like a journey from a village which suffers from open defecation due
But
to
I think paper title should be the same, whatever the journey is.
okay, ma'am.
You will be getting the certificate from this paper title only.
Okay, ma'am.
Okay. Yeah, so paper title is different. That's what my point is. Go ahead.
Okay. Is my screen visible?
So you can share your screen once again.
Yeah. Yeah.
It is visible. Please go ahead.
Thank you. Water, something without which we cannot live our lives. Water is a vital part of our health and plays a key role in many of our body functions. Not just that, it gives us food, keeps us clean, improves blood oxygen circulation, etc. This manuscript highlights the crucial role of water sustainability and sanitation in global development, with a specific focus on Kurvakurda, a village in Karnataka, India. Emphasizing the need of integrated strategies, it addresses the issues like inadequate sanitation, pollution, and water scarcity in Kurvakurda. The infrastructure available. The village of Kurvakurda lacks essential infrastructure, specifically toilets, leading to open defecation. Although there are designated rooms for toilets, they are repurposed for storage or other due to absence of proper sewer system. Please look at the images. Yeah. So these photographs are taken by me when our team visited the village. So I'm sharing with you a first-hand experience. In images 1 and 1.2, you can see this man sleeping in the room, which was supposed to be a toilet room. Toilets have been repurposed as storage or spare rooms. In images 2 and 2.2, depict the condition of sink pits, which are installed instead of sewer systems. As you can see, they have never been used because they don't have the time or proper tools to clean them. Problem identification. Ensuring access to clean water is a fundamental human right, yet it remains a critical challenge, particularly in low-income communities. Kurvakurda faces water contamination primarily due to open defecation, where the act of urinating outside without proper sanitation facilitates poses a significant threat to water sources. This study aims to delineate the issues of water contamination linked to open defecation, its repercussions on human health, and potential remedies. So, water contamination due to open defecation. Water contamination arises as human feces containing various pathogens is left untreated in open areas, significantly affecting the nearby water sources such as rivers, lakes, and wells. Kurvakurda relies on surface water, specifically the river, for essential activities like drinking, cooking,
Your
and
font
washing.
size is not at all visible. Come to the experiment part. So much of it.
Okay, ma'am.
Font size is not at all visible. Please come to the.
Okay, ma'am. So we did our analysis using these PRA tools. There are 6 PRA tools that we'll be using in this experiment. Well, PRA stands for Participatory Rural Appraisal and is an approach that aims to incorporate knowledge and opinions around the people in planning management of rural development projects and programs. Resource map. A resource map, it helps to gather information about a community's resources, infrastructure, and social systems. As you can see, we have drawn a map of the whole village, and there are legends over here on the left side, which tells the resources, plants, houses, etc., that are available in the village. The next one is Transact Walk. Transact Walk involves observing and documenting the different features and characteristics of a particular area by walking along a straight line or a path. So it provides a visual representation of specific areas on the map, indicating various elements such as soils, trees, animals, and vehicles, with a detailed information on a particular cross section of the map. Next is income and expenditure. The horizontal axis depicts the average monthly income, while the vertical axis shows the average monthly expenditure and surplus amount of Kurva Kurda people, with a minimum of 0% and a high of 100%. Groups A, B, C, and D stand for a group of individuals whose monthly incomes are included in the specific range. Next is brainstorming and problem tree analysis. So after gathering all the information, we observed that there were two major problems in the village. First one is water contamination. Reasons: hard water or salt concentration, agricultural waste, drainage, and dead materials. Causes: diarrhea, kidney stones, skin diseases, and knee and body pains. The second major problem was lack of a school. Because there's no school, parents usually bring their kids to their fields to work. This results in kids not going to school, illiteracy, lack of basic education. Next, we have a Venn diagram. A Venn diagram is an important visual tool that can be used to understand the relationship between key institutions and organizations. This can help researchers to comprehend the power dynamics and potential barriers to effective collaboration and participation. So a Venn diagram is an important visual tool that can be utilized to understand the relationship between key institution and organization, as I told earlier. In the diagram, there are circles. As the circle goes farther away from the central dot, that shows the amount of influence this individual or the organization has in the village's roles and responsibilities. Next is seasonal calendar. A seasonal calendar is a participatory tool used to gather information on the seasons for growing crops and or breeding animals, and months of vulnerability, difficulty, opportunities, and threats faced by the communities. As in the image, there are water resources that are available. You can there's an asterisk symbol for each month. So that shows what resources available in what month. For example, borewell can be used, as you can see, borewell can be used in all the months, but rain, it can be only seen in September, October, November. Diseases, fever, cold, flu, sun diseases, skin diseases, typhoid, malaria. So these diseases basically happen because of water. And crops, there are only two major crops grown in the village, and they are grown in March and April, cotton and paddy. Cotton is grown in June, July, August, September, and October. Next is inflow and outflow. Inflow and outflow refers to the movement of resources into and out of the community. Inflow can be referred to resources such as people, money, food, etc., that come into a community from outside. And outflow refers to resources that that leave the community, such as people migrating, goods being sold or exported, or waste being disposed of. In conclusion, this Live-in Lab initiative facilitates the practical implementation of technological interventions for rural development, allowing participants to collaborate with and learn from residents. This program empowers participants to assess, suggest, and enhance the rural needs, utilizing innovation and technology. By implementing water sanitation measures, the program addresses critical health issues, reduces waterborne diseases, and promotes holistic development. Live-in Lab offers a comprehensive approach to development, aiming for less change and improved quality of life in undeserved areas, contributing to all overall socio-matic advancement. Thank you. Are there any questions?
Yeah, how do you, what are the specific challenges or, needs identified in Kurukardha village regarding water sanitization?
Sorry, I didn't get the question.
What specific challenges or needs were identified in the village regarding water sanitization?
There were many challenges actually, because people were conducting open defecation. The groundwater was also getting affected by this, and because people used to store the water, which was very hard water, so there were a lot of mosquito breedings also happening. So people suffered from diarrhea, cholera, etc. because the water and also the field water that was let into the river, so that also contaminates the water. And basically they wanted pure water, an RO water plant, but they couldn't get it. The government has not given them the water plant, so they had to walk kilometers to fetch water from the river, which was also contaminated by their field.
Okay, thank you.
Thank you, ma'am.
Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Praful V. Barekar to present the paper titled Object Detection and Tracking Approach for Traffic Monitoring. Sir, you may start your presentation.
Thank you. Thank you, Ishita. Please let me know my screen is visible or not.
Sure, sir. It is visible now.
Okay. Thank you. Hi everyone, my name is Praful Barekar, presenting a topic, object detection and tracking approach for traffic analysis. And this is what I outlined for our presentation: introduction, objectives, literature survey, what are the different algorithms that are being used for object detection and tracking. Why we have selected YOLO, block diagram.
Come to the objectives and experiment.
Okay, ma'am. So prior to that objectives, I need to just brief what exactly a problem definition is. So that is there in my introduction part. So there are two types of detectors: one-step and two-step detectors. The significant difference between one-step and two-step detectors are two-step detectors are more accurate than one-step, but as far as time parameter is concerned, means time complexity parameter is concerned, then one-step detectors are more fruitful than two-step detectors. So there are certain algorithms which are one-step and two-step. So one-step algorithms are normally YOLO, which is nothing but you only look once, and two-step detector algorithms comes under a category of RCNN, which are region-based convolutional neural networks. So basically, we are trying to focus on one-step detectors, how they are being useful for detecting and tracking traffic flow, and how we are able to take certain decisions when there is more traffic on a road then. Okay, so this is what the theory behind that. So our objective is we are trying to retrain our YOLO. There are various versions of YOLO that are being introduced. So we are basically retraining our model on our customized data set using our customized data set we are providing to YOLO V7 for cars and person. Basically, we are trying to focus on cars and person in that customized data set. So, and we are trying to count the number of objects that are passed through our area, region of interest on a signal or any particular road. A more traffic prone road or squares, then we are trying to keep a track of that particular objects. So this is the theory, means literature survey that we have done. If we want, then we can proceed with it, or we can directly jump on a algorithm. So YOLO V7 has a higher speed and accuracy with a range of 5 to 160 frames per second, and has surpasses all known object detectors in 30 frames per second. So YOLO V7 is trained on MS COCO dataset, which is having around 86 objects of our day-to-day life, and we are able to track and detect them properly with a certain decent amount of accuracy. So basic theory behind YOLO and all that we are going to discuss, like what exactly YOLO algorithm does. It is dividing our complete frame into S by S grid, and it follows a single feed forward propagation through a neural network to detect an object. It's actually a regression model, which is
Please come to
being
the objectives
okay.
and your experiment part. That's it.
Yes, objective we are done with. This is what RCNN, and we are done our experimentation. We are passing our video to a tracking algorithm. Then that video is divided into frames. Then that frames we are passing to our YOLO V7 algorithm, which is a detector algorithm, wherein we are receiving frames as a ND-array object, and we are converting BGR to RGB format. Then we are actually performing detection on that RGB format. Then return detection of frame as a list to a detection per frame received, then calculating a center point of a particular object to track a particular object. Then we are trying to assign a unique ID to that detected object around a bounding box, and we are trying to track it by comparing center with the previous frame of that particular video. So inferencing that we have done on YOLO, wherein confidence level is being calculated for different objects are being shown in this particular table. Then inferencing that is being done on mask RCNN, wherein confidence level on of various objects that have been detected out of a frame are shown in this particular table, wherein we can actually able to compare that confidence score is much more higher in case of mask RCNN or any RCNN model, and rather than YOLO. But it takes more time as it is a two-stage detector, wherein for proposing a region, we need one more convolutional neural network. So two-stage convolutional neural networks, we have to pass our data through two stages, so it will take more time. So that's why we are trying to focus on YOLO only. So YOLO V7 is going to provide us a certain decent results of confidence score. On the basis of that, we are trying to detect an object. So this is what object detection strategy that we are applying. We are trying to detect an object by enabling a bounding box around the cards, and those bounding boxes are being provided with certain unique ID. By evaluating its center point of that particular bounding box, we are trying to assign a unique ID, and we are trying to track that object, whether it is that particular car or not, or whether it is that particular object or not, with the help of this unique ID frame by frame. If the difference is more, then we are changing that particular ID, means we are trying to treat that particular object is something that is being passed through that particular region, and new object is being entered. Okay. So likewise, we are trying to uh, uh, analyze the traffic flow on certain dense squares where traffics are more by enabling our region of interest. Whenever objects are being entered in that particular region of interest, we are trying to uh, detect them with the help of YOLO first. Then we are trying to find out the center of that particular object and assign a unique ID to those particular objects. And we are doing that with the help of our Python scripts. So I have not put that script screenshots in a presentation, but we are trying doing that with the help of Python. So results and conclusion, wherein the YOLO V7 has an retrained on Kaggle dataset consisting of 1.5K of images with two categories as car and person. So tracking approach is being implemented on frames where vehicles are present as an object. So after this experimentation, it is found that the number of epochs in training increases, then model is able to detect the objects in more better way. So with increase in number of epochs of training, the tracking mechanism is able to track the objects with offset of 20 and 25 in 30 frames per second video. So detecting far objects which appear to be small in object image captured by a real-time systems is very important for real-time scenarios. So YOLO V7 is capable of satisfying the various object detection uh, constraints according to the real-time systems. And these are what the different references that we have quoted for our paper. And finally, the acknowledgement that we have tasted that on NVIDIA DGX workstation that is present in our college itself, ICC. And my project is, those are gone through that exhaustive experimentation on a data set and all that I want to acknowledge, like Athar Bwagare, Mohit Kulkarni, Rakhi Khade, Nilay Botman. Thank you. If any questions, I'm open for question.
Thank you, sir. Ma'am Asha, would you like to ask any question?
Thank you so much.
Okay. Thank you, sir.
Thank you, ma'am.
We'll be proceeding with the next paper presentation. I'd like to invite Bhagyashree S. Madan to present her paper titled Review of the Diabetic Retinopathy Prediction Model based on an Enhanced VGH Algorithm. Ma'am, you may start with your presentation. Ma'am Bhagyashree, if you're here. It seems like she's not present. We'll be proceeding with the next presenter for the day. I'd like to invite Diksha Pandit to present her paper titled Right to be Forgotten, a Human Rights-Based Approach for Governance in Generative AI. You may start with your presentation, ma'am.
Hi, Ishita, will you wait for a second? I'll just share
Sure.
my screen.
Sure. No issues.
Is it number 10 starts?
Yeah.
All right. Very good afternoon, everyone. The title of our paper, which is shown in the PPT slide also, that is Right to be Forgotten, human rights-based approach for governance in generative AI. So here I am going to give a brief introduction of this paper. The paper is discuss the role of right to be forgotten in the realm of one of the prominent digitally intelligent technology, that is generative artificial intelligence. And it's also focus the conflicts of interest and rights arising between right to be forgotten and generative artificial models. The research is completely based on doctrinal study. We have included certain case laws, and we also have discussed this right to be forgotten, whether it's a fundamental right or not. And so in 2022, after this KS Puttaswamy judgment, it was recognized as a fundamental right, which is enshrined under Article 21, where it is mentioned right to life and personal liberty. The paper is also included from the start. The paper is included the evolution of this right to be forgotten and how it is connected with generative artificial intelligence. Because under this generative artificial intelligence, there are certain tools which we are using in our daily life. Right. So whether that information is erased from the source or not, right, that should be erased or should not be erased, that should that is given under this right to be forgotten, right? So right to be forgotten regarded as emerging digital right that is essential for the governance in the realm of as I earlier said, realm of generative artificial intelligence. And it is also refer to the ability of a person to limit, delete, and correct the disclosure of personal information. Further, this paper has included evolution and the relation between this right to be forgotten and personality rights in generative AI, followed with certain case laws, mainly this Puttaswamy judgment in India, and is the case laws
Ma'am,
between
please skip this part. Come to the objectives.
All right, this is the main object, ma'am. The main object of this paper to find out what is the role of this right to be forgotten in the realm of this digitally intelligent technology, that is generative artificial intelligence, and how it is implemented and whether it is successful or not, and what are the lacunas in this way. We have included these things in this paper. So my second co-author will discuss all these things one by one. Thank you.
Success in creating AI could be the biggest event in the history of our civilization, but it could also be the last unless we learn how to avoid the risk. Good afternoon, all of you. My name is Diksha Pundir. I am a LLM student of University Institute of Legal Studies, Punjab University, Chandigarh. As my other co-author have given you a brief introduction, I would like to continue from here. As we have discussed, right to be forgotten is an emerging legal right in the field of in the awareness of in the realm of generative artificial intelligence. What is right to be forgotten? Right to be forgotten refers to the ability of individual to limit, delink, delete, or correct the disclosure of personal information on the internet that is misleading, embarrassing, irrelevant, or anachronistic. As we all know, internet is an inexhaustible source of information, and generative AI conjointly with its contemporary technologies, example robotics, are thriving over digital intelligence by data mining on internet. So what we envision as a right to be forgotten in generative AI is a right against both lawful and unlawful utilization, processing, assessment, and application of personal data. What is personal data? Personal data is the information that directly or indirectly discloses the political, physical, psychological, or economic identity of individuals, or non personal data, which concerns the intellectual property rights of individuals of data principle. By data principle, we refers to person or entity to whom personal or non-personal data belongs. Though through this right, before discussing in the next aspect, I want to discuss the role of right to be forgotten in generative AI. Before discussing it, how right to be forgotten has evolved. Rather, journey of right to be forgotten has been from a principle to a legal right. Earlier, it was recognized as a principle in the legal system, but now it has been incorporated as a legal right in the legal system for the governance of various technologies we are going to either we are using such technologies, or we are either going to discover new technologies. This right could be the very a very important human right that can change the governance in the technological field. For example, right to be forgotten in the first approach evolved as a legal principle. Under this, what used to happen that earlier, when it was incorporated as a principle, if a criminal commits a past, then after he has served his sentence, what we could do, he could obligate his past by suppressing the publication of his crimes. In the second approach, it evolved by judicial activism. That is, in the case of Mario Costeja Gonzalez case, what happened? Mr. Mario Costeja, in 1988, he was a Spanish citizen and he entered into a financial distress. When he entered into the financial distress, his properties were auctioned, which was covered by a newspaper, La Vanguardia, in his country. So, as the internet progressed, the information went to online, and therefore, after when a search was made about his name on the internet, that Mr. Costeja Gonzalez, then the newspaper cutting used to come that he was involved in a financial distress, which he in this case said that compromised his privacy and reputation. Therefore, he filed a case in Court of Justice of European Union, where he asked on the grounds that his privacy and reputation are being affected. Therefore, he wants to confine his past into the history by removal of that information. The court in the Court of Justice of European Union for the first time identified this as a legal right that you can have your information confined to history by asking Google and the language online edition to take down that news. In the third approach, right to be forgotten in the present phase is being developed through legislative frameworks via data protection laws. For example, EU's recent Journal Data Protection Regulation, UK's Data Protection Act, India's Digital Personal Data Protection Act has incorporated this as a right. uh, uh, to understand that why right to be forgotten is essential, right to be forgotten strives to establish a harmonious balance between generative AI models, novel content, and economic interest with human rights of data holders. So we are propounding a right that needs to be essential as an important right before to protect people's personality rights in the field of generative AI. As we all know, generative AI models are developed by algorithms by harvesting raw data or organized data from internet, or by developing synthetic data by self-instructing algorithms. Therefore, through our research paper, we are trying to highlight the importance of right to be forgotten in protecting the personality rights of the data holders. The data holders whose data will be used by the generative AI models for training, or either they will be the data generative AI will generate both the input and the output. We are exploring this right in the field of both the input data that will be used and the output data that will be produced, that would be compromised, that would involve the rights of and liabilities of the data holders. Today, personality rights, giving a brief introduction, what are personality rights and what do we personality rights includes the right to physical liberty, privacy, identity, likeness, and image, reputation, dignity, and physical psychological integrity, and right to life sentence, and some other rights. According to Putas, one of the aspect of personality rights is the privacy. According to JSK, Justice.
Excuse me, ma'am. I'm really sorry to interrupt you, but this is a gentle reminder regarding the time limit.
Okay. According to Puttaswamy judgment, right to privacy, very important notion, right to privacy was identified as a fundamental right. In generative AI, we are concerned about the informational privacy and privacy of choice. That is, you are using a personal information of the people to generate your products, and privacy to generate your product and services, and privacy of choice, that is the data that is being used, it is without the consent, whether it is with the consent of the user or without. The right to be forgotten is essentially a remedial right in such a case where there is an unlawful and unauthorized processing of data. For example, in PM versus OpenAI case, a class action lawsuit has been instituted against ChatGPT, Dale and Valid, because they are allegedly violating the autonomy of users. They are using the data of internet users without their consent. So this lawsuit is currently being filed. So and therefore right to be forgotten is a very important role in case there is a violation of autonomy of users, so that the data can be taken down. Also, also there have been various another cases in under which this right has been dealt. For example, in Mark's Walter case, a famous radio host has sued OpenAI for a tort of libel, because whenever search was made of his name, it showed that he was involved in a embezzlement proceedings, but where he was not. So, what could be done when such a reputation rights of a person is violated? Right to be forgotten in this case will ensure that the information is corrected. Similarly, there have been various intellectual property aspect cases also, where, for example, in Young versus Neoctex, plaintiff Kyland Young sued defended Neoctex for commercially exploiting his thousands of well-known individual names, voices, photographs. For example, generative AI, we have come across technologies such as deepfakes, which have led to defects which have led to violation of individuals' personal data. Therefore, right to be forgotten is very essential for the protection of non-personal data as well, when it could be can be used as an injunction, or as a remedial right to protect the violation of non-personal data. So the challenges for implementation of right to be forgotten in generative AI is, firstly, it is lack of legislative framework. RTBF is a very new emerging legal right for data privacy and protection, which it's and taking RTBF generally is a right that is being for the data that is present on the internet. So when we are going to transfer it to a model, where generative AI is generally a model that is extracting, harvesting the data present on the net. So therefore, if we want, it will be very difficult to take a right from a normal purpose to an application based purpose. The second is the legal controversies surrounding RTBF. Right to be forgotten is itself a very not yet contemplated for generative AI. It is only restricted to one or two of its associated subrights. For example, in Google LLC versus CNI, it led to the conclusion that Google India, under its legal obligations, is obligated to delete. Japan will not, and hence generative AI models can exploit these legal loopholes to build their products on the data where such legal obligations of deletion, of correction of data are not there. Also, another challenge is the role of internet intermediaries. The terms and policies of internet intermediaries such as cloud service providers, web hosting service providers are also very biased. They generally tend to resort to policies where they could handle the data as they want. Therefore, it will also serve as a challenge to apply right to be forgotten as a legal right in the digital space. Practical problems would be that data deletion in the database, or relearning of the generative AI models, relearning of data by generative AI models can be very cost effective. So coming to the suggestions, we have provided that social number one is the social contract for data. Tackling data at the very first source can and approaching data governance in a different way can play an important role for creating a very harmonious role for right to be forgotten in the realm of governance of generative AI models. Some principles for social contract for data are notice and consent, collection and purpose, limitation, assess and correction, data minimization.
You've crossed your time limit.
Okay, I'll just conclude in a second. And the segregation at source and technological solutions are given. And conclusion, I would like to conclude that it is a very important, a very essential for RTBF is a very essential part for a transparent, accountable and equivalent governance of GI, so that it could collaborate the human rights with booming technology. Thank you.
Thank you, ma'am. Ma'am Asta, would you like to ask any question?
No, thank you.
Okay. I'd once again like to ask for paper presenter Bhagyashri. If you're here, then you can start your presentation. Since she is not here, that brings us to the conclusion. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 8th version and the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have already been forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team of SMARTCOM 2024. I also thank the session chair, ma'am, Dr. Astha Parikh, for chairing this session, a token of appreciation to the chair on behalf of Team SMARTCOM 2024 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, ma'am.
Thank you, ma'am. I extend my heartfelt gratitude for inviting me to serve as a session chair. And I convey my thanks to the entire organizing committee for the hard work and dedication in putting together such a comprehensive and impactful conference. So each presentation was not only the informative, but also showcased the dedication and expertise of the presenters. So thank you once again for inviting me.
Thank you, ma'am. I'd like to request to everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.